Right, our last section for chapter 2 is scientific notation. Something you'll use a lot more when you get to high school and we're using science. Anytime you are using large numbers, large decimals, or very large numbers, scientific notation just makes the numbers more user-friendly. Start to ignore all those extra zeros when we write in scientific notation. So it is just a way of writing for very large or very small numbers, and we're going to use the powers of 10 to do it. So anytime you have a number that's written like this, 1.8 times 10 to the 4th power is going to be scientific notation. So how do we go back and forth between scientific notation and standard notation? That's what we're going to be working on in this chapter. So let's say we're starting out with 2.64 times 10 to the 7th power. How do we write that in standard notation? What does that even mean? So one way of looking at it is you would have your 2.64 and we've got 7 zeros after this 1. So it's 10 to the 7th power, so you would need to have 7 zeros after the 1. That's 10 million. So you're going to do 10 million times 2.64, which would be 26,400,000, right? So that's kind of the long way, and that's what it means. And I'm going to show you the slightly shorter way of figuring out what the answers are. All right, so we're going to go to scientific notation to standard notation. So we have 1.35 times 10 to the 4th, negative 4th, I'm sorry. The first thing you want to look at is your exponent. If you have a negative exponent, then we're going to move the decimal to the left. If you have a positive exponent, we're going to move our decimal to the right. So in this case, we're going to go left 4 places. So we're going to start at our decimal and we're going to move 1, 2, 3, 4. There's our new decimal. We're going to fill in all these extras with zeros. So our answer is 0.000135. All right, let's try this one. In this case, we have a negative 5.8 times 10 to the 6th. This negative, be very careful, has no bearing on whether we move right or left when we're moving our decimal. It's the exponent if it's positive or negative. In this case, it's positive, so we're going to be moving to the right. We're going to move 6 places, including that 8. So how many zeros are we going to add after the 8? We're going to add 5 because the 8 is 1 place and then we need 5 more places. So there'll be 5 zeros. So in that case, our answer is going to be negative 5,800,000. So let's say we're going the opposite direction. We have standard notation and we want to move to scientific notation. Pretty simple to write it out at first. The numbers that are back here are the numbers that are going to be in scientific notation. So we're going to have 2.0 times 10, because that's what scientific notation is. What we need to know is what the exponent is. So if we are starting from a small decimal number, our exponent is going to be a negative. If we're starting from a big number, billions, millions, whatever, then our exponent is going to be a positive. So we just need to know how many spaces we're moving this decimal. So let's count that. We're moving at 1, 2, 3, 4, 5, 6. So this is going to be 2.0 times 10 to the negative 6. So if you're moving from standard notation to scientific, if you're moving that direction, now it's a negative. And if we move this direction, then it is a positive.